let's try to solve Leetcode 111, minimum depth of binary tree. So this is similar to maximum depth of binary tree, but it's going to be a little bit harder. So we need to understand what's going to be the definition of minimum depth of binary tree. We need to check all the depths. So for example, we need to find all the bronze. So this is 3 and 9. This is one path. This is another path, 3, 20, and 15, and this is the third path. So for this path, the depth is 3, and for this path, it is 3. This is 2. So the minimum gonna be 2. So we're gonna return 2. So this is the definition. So for some other examples, maybe we have node 1, node 2, node 3. So what's gonna be the minimum depth? Because we have only one path and the depth is 3, so we're going to return 3 instead of 0, because for instead of 1, because for this node 1 at the left side there's nothing, but we will not count it as 1, we will count it as 3. We need to find all the paths, because at the left side there's no such path. So if we understand the definition, normally we should know how to solve it. So the condition is that we need to check the root. If this root equal to none, we're gonna return a 0. Yeah. Now we need to check the case if at the left side there's none, and to the right side there's a subtree. We need to check that. Yeah. If root dot left equal to none, and root dot right not equal to none. Yeah, if it is like that, we can directly have a return. It's going to be 1, so for this node 3, it has a depth of 1, plus, because at the left side there's nothing, so this means we need to plus the right side. So the right side is going to be the minimum depth of the root dot right. As the recursive function, it is always symmetric, especially for a binary tree problem. So this is a binary tree problem, so we can check the we can just change a little bit. If the left side is not equal to none, but the right side equal to none, and here gonna be the left. Yeah. So another case is that the left side is not equal to none, and the right side is not equal to none, and we just need to check the minimum of the two cases. Yeah. So we're gonna call the max the minimum of the depth, the root dot left, and the minimum of depth, and root dot right. Yeah. So in this way, we checked all the cases. I believe it's going to be okay. Now let me just run it. Oh, it didn't work. I got it. So my output is 0. It should be 2 for the first case. Let me just check why. So from the right side, if I have something, I'm gonna use 1 plus minimum depth root dot right. And if the left side I have something, oh yeah, because here I use the max, it's gonna be the minimum of the two. The minimum of the two. So the minimum depth. Oh, I did something wrong. If root dot left equal to none and root dot right not equal to none, I'm gonna use 1 plus the minimum depth root dot right. If the left not equal to none and the root dot right equal to none, I'm gonna use 1 plus root dot left. Otherwise, it's gonna be the minimum of the two. Yeah. Let me just make a comment. I don't know why it is wrong. Let me just return any value like 100. Yeah, for the first example, it is 100. It is okay because I just returned that 100. um, it's gonna be the minimum of the two. Yeah, let me just return a 1 to check what is wrong. The minimum of the two, so mean depth root dot left. I'm gonna check this one. This one gonna be a 1, and this one gonna be a 2. The minimum gonna be 1. Yeah, because I forgot to plus 1. So for example, if this node 3 has a left subtree and it has a right subtree, so I'm gonna choose the minimum of the two, but I still need to plus it. Yeah, this is why I did it wrong. Now let me just run it. Now as you can see, it should be okay because I forgot to plus this one, because this node also count. This is 1 plus the minimum of the left side, minimum of the left side and the right side, minimum of the left side and the right side. I still need to count this one. This is the root node. I need to plus 1. Yeah. Now let me just submit it to check if it works. As you can see, it passed for all testing cases, and it's pretty fast, and the time complexity is O(n). So n is the number of the node. I think that's all about it. Thanks for watching.